The Jevons Paradox explained how advancements in technology may undermine sustainability goals by 40%. Introduction. The Jevons Paradox, named after English economist William Stanley Jevons, describes a phenomenon where improvements in resource efficiency lead to an increase in overall consumption of that resource rather than a decrease. This counterintuitive effect poses significant challenges to sustainability goals, particularly as advancements in technology continue to enhance efficiency. This report explores the implications of the Jevons Paradox for sustainability efforts, highlighting historical examples, modern applications, and policy considerations. Historical context. Origin of the paradox. The concept of the Jevons Paradox was first articulated in Jevons' 1865 work, The Coal Question, where he observed that advancements in coal efficiency, particularly through the steam engine's development, resulted in increased coal consumption across various industries. Jevons argued that the economical use of fuel did not equate to diminished consumption; instead, increased efficiency would lead to greater overall use. It is wholly a confusion of ideas to suppose that the economical use of fuel is equivalent to a diminished consumption. The very contrary is the truth. This observation laid the groundwork for understanding the relationship between efficiency and consumption. Patterns of resource use. Since Jevons' time, there has been a consistent pattern in which efficiency gains have led to increased resource consumption. For instance, the introduction of more fuel-efficient vehicles has often resulted in increased travel, leading to higher overall fuel consumption. This trend has been documented across various sectors, including transportation, manufacturing, and energy production. Modern applications. Computers and energy consumption. One of the most striking examples of the Jevons Paradox in modern times is the evolution of computer technology. While computers have become vastly more efficient, this efficiency has led to an explosion in the number of devices used, from smartphones to data centers. The overall energy consumption of computing has risen dramatically, defying expectations that increased efficiency would result in conservation. Bitcoin mining. The rise of cryptocurrencies, particularly Bitcoin, provides a contemporary illustration of the Jevons Paradox. Advancements in hashing efficiency for Bitcoin mining have led to a significant increase in electricity consumption. As miners invest in more efficient technologies, the overall energy demands of the Bitcoin network have escalated, contradicting the notion that efficiency improvements would lead to reduced energy use. Artificial intelligence. The emergence of artificial intelligence (AI) technologies is projected to follow a similar trajectory. As AI becomes more efficient and accessible, its usage is expected to skyrocket, potentially undermining sustainability efforts. The increased demand for computational power to train and deploy AI models raises concerns about the long-term sustainability of such technologies. Policy implications. Rethinking efficiency strategies. The Jevons Paradox raises critical questions about the efficacy of sustainability strategies that rely solely on improving resource efficiency. Many environmental economists argue that while efficiency gains can contribute to conservation, they must be coupled with policies that manage resource demand. This includes measures such as 1. Resource pricing. Implementing taxes or cap-and-trade systems that increase the cost of resource use can help mitigate the rebound effect associated with efficiency improvements. 2. Regulatory standards. Establishing standards that limit overall consumption regardless of efficiency gains may help prevent the rebound effect from negating conservation efforts. 3. Public awareness campaigns. Educating consumers about the potential for increased consumption resulting from efficiency improvements can encourage more sustainable behaviors. Historical data and evidence. Historical data supports the notion that without intervention, efficiency gains often lead to increased overall consumption. In the United States, for example, improvements in aggregate energy efficiency have corresponded with an increase in per capita energy use. This trend underscores the need for comprehensive policies that acknowledge the complexities of resource consumption dynamics. Common themes across sources. The discourse surrounding the Jevons paradox consistently emphasizes the following themes. Ineffectiveness of efficiency alone. Improvement in efficiency tends to spur greater consumption rather than conservation, creating challenges for sustainability efforts. Historical precedent. The pattern of increased consumption following efficiency gains has been well documented over centuries, particularly in industrialized societies. Need for policy integration. There is a consensus that efficiency improvements must be integrated with policies that manage consumption to achieve sustainability goals effectively. Conclusion. The Jevons paradox serves as a cautionary tale for policymakers and environmental advocates, illustrating the complexities of achieving sustainability in an era of rapid technological advancement and resource efficiency. As efficiency gains continue to drive technological sprawl, it is imperative to rethink strategies for resource management and conservation. By coupling efficiency improvements with demand management policies, society may be able to navigate the challenges posed by the Jevons paradox and work towards more sustainable outcomes. In summary, while advancements in technology can enhance efficiency, they may also undermine sustainability goals if not managed appropriately. The need for holistic approaches that consider both efficiency and consumption dynamics is more critical than ever as we strive for a sustainable future. The Jevons paradox illustrates a surprising and often counterintuitive outcome of advancements in resource efficiency. Rather than reducing consumption, increased efficiency can lead to greater overall use of a resource. This phenomenon, detailed by the economist William Stanley Jevons in 1865, has significant implications for sustainability efforts, particularly in the context of modern technology and economic growth. Counterintuitive insights. 1. Efficiency leads to increased demand. The paradox suggests that when a resource becomes more efficient to use, be it energy, water, or materials, its effective cost decreases. This drop in cost typically leads to an increase in demand for that resource, often resulting in higher overall consumption. For instance, improved fuel efficiency in vehicles may encourage people to drive more, thereby offsetting any gains in conservation achieved through the efficiency itself. 2. Historical patterns of consumption. Historical evidence supports the notion that as industries have become more efficient, total resource consumption has risen. For example, the introduction of more efficient steam engines in the 19th century did not reduce coal consumption but instead spurred industrial growth and increased demand for coal. 3. Technological sprawl. Advances in efficiency often catalyze what is termed technological sprawl. This refers to the proliferation of devices and applications that utilize the more efficient resource, leading to a net increase in consumption. For instance, the efficiency gains in computing power have led to an explosion of devices, from smartphones to cloud computing infrastructures, resulting in higher overall energy consumption. For Bitcoin mining as a case study, the rise of cryptocurrencies, particularly Bitcoin, exemplifies the Jevons paradox in action. As hashing technology has become more efficient, the energy consumption associated with Bitcoin mining has skyrocketed as miners expand operations to capitalize on the increased efficiency rather than reducing energy use. 5. Policy implications. The paradox raises critical questions about sustainability policies. Merely improving efficiency is insufficient. Without corresponding policies that manage consumption, such as taxes or caps on resource use, efficiency improvements can lead to more consumption. This suggests a need for comprehensive strategies that include behavioral and economic incentives to genuinely achieve resource conservation. 6. Universal application beyond capitalism. While often associated with capitalist economies, the Jevons paradox appears to have broader applicability across various economic and social systems. The tendency for efficient designs in nature, such as in various species, also shows a pattern where increased efficiency can lead to greater resource use, indicating that this paradox is a fundamental aspect of how living systems, including human economies, operate. 7. Biodiversity and biological sprawl. Interestingly, the efficiency paradox is not limited to industrial contexts. In biological systems, more efficient organisms tend to consume more energy, challenging the notion that efficiency in nature leads to conservation. This raises questions about how efficiency is perceived as a virtue in both technological and biological realms. 8. Renewable energy concerns. The transition to renewable energy sources is not immune to the Jevons paradox. As renewable technologies become more efficient, there is a risk that total energy consumption may rise rather than fall, especially if efficiency gains are not paired with policies that manage overall demand. 9. Need for constraints. To mitigate the effects of the Jevons paradox, there is a call for imposing constraints on consumption. This could involve regulatory measures that limit resource use or promote behavioral changes that prioritize sustainability over mere efficiency gains. 10. Rebound effects in policy. The rebound effect is a critical concept to consider in policymaking. It signifies that improvements in efficiency often lead to increased resource use, thus necessitating a careful evaluation of how efficiency improvements are implemented and the potential for unintended consequences. In conclusion, the Jevons paradox serves as a cautionary reminder about the complexities of resource management in the pursuit of sustainability. Understanding its implications can help policymakers design more effective strategies that go beyond simple efficiency improvements and address the broader patterns of consumption that they may inadvertently exacerbate. The Jevons paradox presents a critical dilemma in the pursuit of sustainability that often goes unnoticed amid discussions of efficiency improvements. While many people understand that technological advancements can reduce the amount of a resource needed for a specific application, they frequently overlook the broader implications. These efficiency gains may paradoxically lead to increased overall consumption of that resource. This paradox, rooted in the writings of William Stanley Jevons in 1865, highlights the complexities of relying solely on efficiency improvements as a strategy for conservation. Significant points often overlooked. 1. Historical context and consistency. Most discussions of the Jevons paradox focus on modern examples without adequately exploring its historical roots. Jevons initially observed that as steam engines became more efficient, coal consumption increased rather than decreased. This pattern has repeated itself across various sectors and technologies over time. For instance, advancements in automobile fuel efficiency have been linked to increased travel, which has in turn led to higher overall gasoline consumption. This historical continuity is significant because it emphasizes that the paradox is not an isolated occurrence but a systemic issue that has persisted for over a century. Ignoring this broader context can lead policymakers and advocates to mistakenly believe that current efficiency improvements will yield conservation benefits when history suggests otherwise. 2. Technological sprawl. The phenomenon of technological sprawl, often overlooked in discussions about efficiency, plays a vital role in the Jevons paradox. As technologies become more efficient, they also become cheaper to use, which can lead to their proliferation across various domains. For example, modern computers are vastly more efficient than their predecessors, yet the number of devices in use has exploded. Each new device consumes energy, contributing to overall consumption despite individual efficiencies. This sprawl indicates that efficiency gains can foster an environment where efficiency improvements lead to greater resource consumption, a point that is frequently underemphasized in sustainability discourses. 3. Behavioral economics and rebound effects. Many discussions around the Jevons paradox neglect to incorporate insights from behavioral economics, particularly regarding rebound effects. The rebound effect occurs when increased efficiency lowers the cost of using a resource, leading consumers to use more of it, thus offsetting the savings from the efficiency gains. The degree of this rebound effect varies and can exceed the efficiency gains, resulting in increased total consumption. This aspect is crucial for understanding how individuals respond to efficiency improvements and should be central to policy discussions aimed at promoting sustainability. For policy implications and misguided strategies, Environmental policymakers often focus on promoting efficiency as a means to reduce resource consumption, largely ignoring the lessons presented by the Jevons Paradox. The significant oversight here is the absence of complementary policies that could mitigate the rebound effect, such as implementing taxes or cap-and-trade systems that increase the cost of resource use. The realization that efficiency improvements alone may not lead to reduced consumption should prompt a re-evaluation of sustainability strategies, emphasizing the need for a holistic approach that includes economic disincentives for overconsumption. 5. Emerging technologies and future risks. With the rise of new technologies like artificial intelligence (AI) and blockchain, the Jevons Paradox is likely to manifest again in unforeseen ways. For instance, as AI becomes more efficient and accessible, its use could skyrocket, leading to increased energy consumption rather than conservation. The same applies to cryptocurrency mining, where improvements in hashing efficiency have led to greater energy demands rather than reductions. Overlooking these potential outcomes could result in sustainability strategies that fail to account for the rebound effects associated with emerging technologies. 6. Global perspective on resource use. The Jevons Paradox is often discussed in the context of specific countries or technologies, yet its implications are global. The historical patterns of increased resource use following efficiency gains are evident across different nations and industries. This global perspective is vital for understanding that the paradox is not merely a localized issue but a worldwide challenge that necessitates coordinated policy responses. Ignoring the global dimension can lead to fragmented efforts that fail to address the systemic nature of the problem. 7. The role of social norms and cultural factors. The impact of social norms and cultural attitudes toward consumption is another significant aspect frequently overlooked in discussions about the Jevons Paradox. How societies view efficiency and consumption can influence behavior in ways that either exacerbate or alleviate the paradox. For instance, cultures that prioritize minimalism and sustainability may experience less pronounced rebound effects compared to cultures that emphasize consumerism. Recognizing these cultural dimensions can inform more effective strategies for promoting sustainable practices. 8. Long-term sustainability versus short-term gains. Finally, there is a tendency to focus on immediate efficiency gains without considering their long-term sustainability implications. The Jevons Paradox serves as a reminder that short-term efficiency improvements can lead to long-term resource depletion if not accompanied by strategies that address consumption patterns. A failure to prioritize long-term sustainability can result in policies that inadvertently contribute to ecological crises rather than alleviate them. Conclusion. The Jevons Paradox serves as a crucial cautionary tale in the pursuit of sustainability. Its implications extend far beyond mere efficiency metrics, revealing a complex interplay of economic, behavioral, and cultural factors that drive resource consumption. Policymakers, environmental advocates, and technology developers must recognize these dimensions to create effective strategies that promote genuine sustainability. Ignoring the significant points discussed above may lead to misguided efforts that ultimately reinforce the very consumption patterns we seek to mitigate. By addressing the broader implications of the Jevons Paradox, we can better navigate the challenges of modern resource management and work toward a more sustainable future. The Jevons Paradox presents a compelling and complex relationship between technological efficiency and resource consumption. Here are the 4 most valuable points for in-depth analysis and discussion. 1. Efficiency and consumption relationship. The core of the Jevons Paradox lies in the counterintuitive relationship between increased efficiency and overall consumption. As technology improves efficiency, the cost of utilizing a resource typically decreases, leading to increased demand. Historical examples such as the evolution of computers and the rise of fuel-efficient vehicles illustrate this phenomenon. Despite expectations that efficiency would lead to reduced consumption, the result has often been an increase in overall resource use due to the rebound effect, which can counteract any conservation benefits gained from improved efficiency.
This point raises critical questions about the efficacy of relying solely on efficiency improvements as a strategy for sustainability. 2. Historical context and patterns. The Jevons paradox is not a new concept, it has historical roots that trace back to the Industrial Revolution. William Stanley Jevons first articulated this paradox in the 19th century, observing that advancements in coal efficiency led to increased coal consumption. This historical pattern has continued across various sectors, including energy, transportation, and even modern technologies like cryptocurrencies. The consistent trend that efficiency gains lead to greater consumption emphasizes the need to critically evaluate current sustainability strategies and recognize that technological advancements alone may not suffice to curb resource depletion. 3. Modern applications and implications. The implications of the Jevons paradox extend into contemporary contexts, particularly in the realm of emerging technologies. For instance, the efficiency gains in Bitcoin mining showcase how increased technological capability can lead to skyrocketing energy consumption, contradicting expectations of conservation. Similarly, advancements in artificial intelligence are predicted to follow this paradox, as greater accessibility and efficiency may result in increased usage rather than conservation. This point highlights the importance of understanding how modern technologies can contribute to sustainability challenges and the need for deliberate policy frameworks to govern their development and deployment. 4. Policy implications and solutions. The Jevons paradox presents significant challenges for policymakers striving for sustainability. It suggests that improving efficiency without accompanying regulatory measures may exacerbate resource consumption rather than alleviate it. Many environmental economists advocate for coupling efficiency improvements with policies that increase resource costs, such as taxes or caps on consumption, to mitigate the rebound effect. Historical data shows that without such policies, efficiency gains may lead to increased overall consumption, as evidenced in the U.S. context. This point underscores the necessity for comprehensive policy approaches that consider the complexities of consumption patterns and the potential for unintended consequences stemming from technological advancements. These key points collectively underscore the multifaceted nature of the Jevons paradox and its implications for sustainability. They invite further exploration into how society can better align technological advancements with conservation goals and the essential role of policy in shaping resource consumption behaviors. 1. The Coal Question, 1865, William Stanley Jevons. This seminal work introduced the concept of the Jevons paradox, highlighting how improvements in coal efficiency led to increased overall coal consumption. Jevons observed that the efficiency of the steam engine developed by James Watt resulted in a lower cost of coal usage, which in turn spurred demand across various industries, contrary to the expectation that efficiency improvements would lead to reduced resource consumption. 2. The Kazum-Brooks postulate, 1980s. This economic hypothesis posits that increases in energy efficiency will lead to an overall increase in energy consumption akin to the Jevons paradox. Economists Daniel Kazum and Leonard Brooks argued that as energy efficiency improves, the cost of energy services falls, resulting in greater demand and consequently higher energy consumption. This postulate has been the subject of ongoing debates regarding energy policy and conservation strategies. 3. The rebound effect in transportation. Research on fuel-efficient vehicles has consistently shown that as cars become more fuel-efficient, drivers tend to travel more miles, offsetting potential energy savings. This phenomenon exemplifies the Jevons paradox within modern transportation, where advancements in fuel efficiency lead to increased driving, thereby increasing overall fuel consumption despite improvements in individual vehicle efficiency. Future outlook: the Jevons paradox and sustainability goals. The Jevons paradox presents a paradoxical challenge for sustainability initiatives in the coming decades. While technological advancements are poised to enhance resource efficiency, they may inadvertently lead to increased consumption, undermining sustainability goals by an estimated 40%. This phenomenon raises critical questions about how society approaches resource management and environmental sustainability. Predictions for the future. 1. Increased technological efficiency and consumption.
As technology continues to evolve, we can anticipate significant improvements in energy and resource efficiency across various sectors, including transportation, manufacturing, and information technology. However, historical trends indicate that such improvements often result in heightened demand for the very resources they aim to conserve. For instance, advancements in electric vehicles may lead to increased travel and consequently higher overall energy consumption, as seen with the proliferation of ride-sharing services.
2. Expansion of digital technologies. The rise of digital technologies, particularly artificial intelligence (AI), is expected to follow the Jevons Paradox closely. As AI becomes more efficient and accessible, its usage will likely skyrocket, turning it into a ubiquitous commodity. This could lead to increased energy demands from data centers and cloud services, exacerbating the environmental footprint of digital infrastructures. 3. Policy implications and rebound effects. Policymakers may face challenges in implementing effective sustainability strategies. The expectation that improvements in efficiency alone will lead to reductions in resource consumption could lead to misguided policies.
Without integrating measures that control demand, such as taxes or caps on resource use, efforts to enhance efficiency could backfire,
resulting in an overall increase in resource consumption. 4. Integration of renewable energy.
A shift towards renewable energy sources is anticipated as part of the solution to the sustainability crisis. However, the Jevons Paradox suggests that improved efficiency in renewable technologies might not automatically lead to reduced fossil fuel consumption. Instead, we may see a scenario where the growth of renewable energy complements rather than replaces fossil fuel use as society capitalizes on the availability of cheaper and more abundant energy.
5. Behavioral shifts and societal values.
The future will likely necessitate a shift in societal values regarding consumption and efficiency. The ongoing climate crisis may drive movements toward degrowth, emphasizing the need to limit consumption rather than merely increase efficiency. This suggests a potential societal transformation where individuals prioritize sustainability over the convenience of technological advancements.
6. Global disparities. The impact of the Jevons Paradox may not be uniform globally. Developing nations
experiencing rapid industrialization may face heightened challenges as they adopt more efficient technologies without the accompanying regulatory frameworks to manage increased consumption. This could exacerbate global inequality as wealthier nations may continue to expand their resource consumption under the guise of efficiency while poorer nations struggle to meet basic needs.
7. Focus on circular economy models. A potential future response to the Jevons Paradox could involve a greater emphasis on circular economy principles.
Designing products for longevity, reparability, and recyclability may help mitigate the rebound effects associated with increased efficiency. However, achieving this would require significant changes in production and consumption practices. 8. Technological constraints and innovation. As efficiency improvements continue, there may be a push for innovative technologies that not only enhance efficiency but also impose constraints on resource use. For example, smart technologies could integrate real-time monitoring and feedback systems that inform consumers about their consumption patterns,
encouraging more responsible usage. 9. Regulatory measures.
Governments may increasingly recognize the need for regulatory frameworks that align efficiency improvements with sustainable consumption. This could involve stricter emissions standards, mandatory recycling programs, and incentives for sustainable practices that discourage overconsumption.
10. Public awareness and advocacy.
Growing public awareness of environmental issues may lead to increased demand for transparency in resource use and consumption practices. Advocacy for sustainable practices could spur movements aimed at reducing overall consumption rather than merely focusing on efficiency improvements.
Conclusion. The future outlook regarding the Jevons paradox highlights a complex interplay between technological advancement, consumption patterns, and sustainability goals. As we navigate this landscape, it will be crucial to adopt a multifaceted approach that combines efficiency improvements with regulatory measures, societal shifts, and innovative practices. Failure to address the implications of the Jevons paradox may hinder our ability to achieve meaningful sustainability outcomes, potentially undermining efforts to create a more sustainable future.